Well, the Microsoft use one channel for everything, don't they? So it
Yeah,
works for Microsoft.
true, true. Yeah, yeah, that's true. I think we kind of started looking at doing that when Liam, Jonathan, and a few of us created Azure-ish brand.
Well,
That was what that was for.
the Microsoft use. Oh, hold on. There's an echo there.
Yep, yep. That was me going live on YouTube. There's a
All
delay,
right.
like a satellite delay, so I had to mute the tab. Can everyone see my screen? I don't know if it's
Yep.
sharing at the moment.
Yep.
Okay, oh, there we are. That's fine. It wasn't appearing on YouTube, but that's that delay. Good. So thanks everyone for coming along to tonight's Knots IoT. Before we get going, and if it lets me move the slides on, we have a code of conduct in place here. Really, it's that bottom right love down there, the heart emoji. If we're all kind, then everything will work out fine. If anybody feels like our code of conduct has been broken in any way, then please do send me a direct message in the chat here in Zoom, and I'll do my best to make sure that the situation is rectified and keep you up to date with what that's doing. Moving on, we are sponsored by Raspberry Pi. Every now and again, they send us some nice kit that we can give away. I don't have any of that today, but in the future, we may well have some of that. We're also sponsored by Rebel, who are a Nottingham-based ethical recruitment company. They sponsor us the Zoom license through which we're using today, and very nice of them it is too. They also sponsor my other user group, .NET Knots, with things like pizza and drinks, so that's nice. And PJG Creations is my side company there, which is sponsoring all of the hosting and that side of things, so that gets to get a spot on there as well. You've got 3 MVPs on this call today. And a Microsoft MVP is an award which is given to contributors who go around in the Microsoft space, either contributing to open source or giving talks at events, like you'll find Cliff doing tonight, for instance, and that John did in last month's event, or perhaps writing blogs or organising events like I'm doing tonight as well. And then once you become an MVP, you get to work closely with the product groups and the folks at Microsoft to be able to help guide direction of products and get earlier access to stuff as well, so that you can be part of that shaping journey, and it can be quite a rewarding process. So if you're interested in that, I'm sure that myself, Cliff, and John would be happy to speak to you about that process if that's something that interests you going forwards. Tonight we've got April talking about AI for learning IoT, and we've got Cliff talking about actually using IoT to secure aircraft, and more words in that title that I've also forgotten. So that it says TBA in there, but you know, timings, and Cliff likes to be mysterious. That's why he's left it to the last minute. Upcoming meetups, we don't actually have any, so that is it at the minute, but there will be another meetup. There was likely, in fact, what I should talk about is that we've got, and I've not put it in, but we've got Loose Carter at .NET Knots a week on Monday. So I think that's the 27th, is it? Somewhere around there, Monday the 27th at 6 o'clock. That'll be on Zoom as well, but it won't be on Zoom, sorry, this month. It'll be in person only, so you'll need to be in and around Nottingham for that one. It's a workshop. We might try and record some content and put that out later maybe, but we'll see. Normally we're hybrid, so keep your eyes, if you're interested in the Microsoft space generally, keep your eyes on the .NET Knots meetup there as well. And with that, I will stop waffling and hand over to April for her talk. So let me stop sharing.
All right, let me go ahead and share. And I'm going to make sure I share with sound, because at one point I have a demo with some audio in it. So I think I am good to go. And here we are. Perfect. So everyone can see my screen?
Oh, yeah.
Okay, perfect. All right. Thanks again, everyone, for joining. My name's April Gittens. I am a principal cloud advocate at Microsoft. I lead our Python cloud advocacy team. And today I'm here to share with you more about how I've been leveraging AI for learning IoT, learning electronics. Rather than an instructional how to use AI, this is more framed around my own story of how I've come to use AI to help me in my journey of learning electronics. And so with that said, we shall begin. So, oops, sorry, let me back up. Okay. So it all actually started with my desire to control more. In 2024, I went to the Game Awards and I wasn't too impressed with too many of the video games that were either nominated or awarded. And it's not that the games were bad, it was just they weren't my personal cup of tea. So that night, I sat next to my best friend. I was her date for the evening, and I whispered over to her that I would be more into gaming if there was an actual game that like was made for me, a game that I would like to play. And so she looked at me and she was just like, well, you could just make one. And technically, she was right. I could actually go make a game. There was nothing that was stopping me. There's already a lot of indie game devs in the game community. But the creation part wasn't necessarily my primary concern. My primary concern was that I didn't have a personal computer that could handle Unity without crashing. So I was an XR dev, so extended reality dev at the time, and so therefore Unity was my game engine of choice. For my work computer, I have an Alienware Tower, which was beautiful for doing anything with XR development. But in my personal life, I had a MacBook. And the MacBook that I have, I did not configure it for any sort of extreme like development. And so therefore I needed something different. Not to mention keeping personal life off of the work machine is a really big thing. You don't want to get into any potential issues in the future around ownership when you're creating any IP. So I needed to have my own solution there. So I thought to myself, okay, what should I do? The obvious choice was build a PC. But I also thought to myself, well, I don't know anything about building PCs, let alone anything about hardware. And something that evening changed the way I thought about it, because when I got home, I couldn't shake the notion of just building a PC. And so I started watching YouTube videos from different guys building PCs. And that's how I learned about PC Part Picker. And from going on there, I realized that there was still some gaps of knowledge. And so while I have friends who have built PCs, for the amount of questions that I had, I felt like it wasn't an appropriate use of their time to consistently reach out for help. And that's when I realized I could probably use AI to help me figure this out and to fill in those gaps. That's when I turned to Perplexity. This was at a time where Perplexity was one of the few AI assistants available that could browse the internet. And so it was really being advertised as like the one that you can use to like do any searches around like shopping and things of that nature. And so I figured, hey, maybe I give Perplexity a try and have it help me fill in the gaps of what it is that I needed. The other thing I ran into was that a lot of the YouTube videos that I watched for PC building was very focused on building a PC for playing games, not for the creation of stuff. And so I needed to make sure anything that I was buying was necessary for what my actual needs were. And that was around creating, whether it was creating in Unity or doing the many things that I do in Adobe Creative Cloud and being able to run everything simultaneously as well. I gave Perplexity a prompt that told it what it is that I tend to use a computer for on a day-to-day basis. And for what I felt to be the first time ever, I had a direction of where to start in terms of what to actually purchase for this particular build that I was doing. That was something that I could not just easily receive from watching a YouTube video. It wasn't something that I could easily receive from just going to chat with a friend. While I may have gotten some level of a direction by using either of those two options, I didn't necessarily get concrete answers for what it is I needed. Not to mention figuring out which parts actually were worth it or not. And this is where I really was glad that I used Perplexity, because not only did it recommend what to consider, it also gave me summaries from various blog posts that different folks have written or different reviews that people have written on some parts. So rather than me having to go surface all that information, it all came to me relatively quickly, saved me a lot of time. And once I had narrowed down the components I wanted, Perplexity also helped me find the best prices as well. So I went on ahead and I purchased the supplies, headed right into building my PC. So in hindsight, here I am a couple years later, PC building is actually a relatively simple thing, assuming you know how to follow directions. And I hadn't realized that when I got started. I went into this process terrified because I didn't know what was going on. But this build took me 2 days, could have finished it in the afternoon, but I was also documenting the entire process for a YouTube video. And so I had to go a little slower. However, I did realize that I was very capable of building this PC that I have here on the screen. And I was really glad that I actually moved forward with doing it because it made me feel like, hey, I can actually like do this. I can do things with electronics. But I think I was mostly scared because on the last slide, I had put a link to where more information about my PC build is. And you may have seen this build was over $3,000. I was scared to lose my money. So I wanted to make sure that I didn't break anything. But fortunately, it turned out very well. And I also learned in that process that it was actually relatively helpful for figuring things out. And so given that PC building was a brand new territory for me, I didn't possess all the necessary vocabulary to get help when starting with this PC build. There was definitely some big gaps on what to call things, but generative AI didn't care. So long as I just described plainly what an issue was or what I had ran into, then I was able to use ChatGPT and Claude to fill in those gaps and get exactly what it was that I had needed. So that really made a big difference. I did make mistakes in the process. For example, when I attached the motherboard to the computer, I didn't use standoffs. That was not intentional. It was very unintentional. I just attached it directly to the case. Fortunately, nothing shorted, but I only knew that something was wrong when guys were commenting on my YouTube video telling me that like, hey, I don't see this, that, and the third. And that's when I realized, well, first of all, what are they talking about? And so I went to use either ChatGPT or Claude to ask. And that's when I figured out what it was I needed. And so overall, doing this build, it helped me gain a ton of confidence, but it also became that turning point for me, not just in building, but also just how much I could leverage generative AI in doing the builds as a whole. And so I had spent years, like literally years, telling like myself and others that I just wasn't a hardware person. But you have to be very careful with respect to how you speak about yourself, because that particular limiting belief is what kept me away from the possibility of even trying to learn about hardware and electronics for years. Completing this build did make me wonder, like, well, what else could I make? So during this period, the AI hype cycle was kicking into full force. And it was exciting in the beginning stages, but I actually started to get bored with just AI as a concept. And so in 2024, I went to New York for a work event, and I spent some time chatting with one of my colleagues about just the general state of AI. And I can be very blunt sometimes with respect to like my own industry, my own opinions on the state of the industry. And so mid-conversation, I looked at him and I went, I'm already ready for the next big thing. And he was just shocked. He was like, what? Like, what do you mean? AI is the next big thing. It'll continue to be the next big thing for a couple of years. But you see, this wasn't my first AI rodeo. A lot of people are getting introduced to AI more recently as we saw the come up of generative AI. But I actually had entered the AI space in 2018. I started creating AI assistants and chatbots and focusing on conversational design during that time. And I did work with Twilio's platform and gave talks at their own conference Signal on just building AI assistants and chatbots. And I've always been a fan of exploring what's new or whatever's like budding on the horizon. And so in 2019, for example, I started learning about XR development, and I spent 4 years doing that directly. And in that space, I started building immersive educational experiences. But because I had that background in chatbots, I was also integrating them into my XR experiences. So I was already using AI at the time, a different flavor of it. Then I started getting into robots as well. I had a tiny, tiny stint in robotics. I was able to get my hands on a Misty from Misty Robotics, and I had programmed Misty to take photos of me and send them to my best friend. I also programmed Misty to do a dance routine to Mr. Roboto. It was super duper cute. And if you follow where I'm at in this timeline of tech in terms of the industry, of course, I then explored crypto. Of course, I explored NFTs. So by the time that we got to generative AI and it became mainstream, my excitement in AI was starting to wane. So I wanted to explore like that next big thing. And as a sidebar, to this day, whenever I chat with that coworker of mine, he always jokes and asks me like, is this the next big thing? Whenever like I bring something up, but that's just how I felt. I wanted to know what was that next big thing. The bigger problem was that at the time, I was on the AI team at my job. And so it was my job to do AI. And so I had to be interested in AI as well. So after a little bit of a soul searching, I reframed my thinking, realized that I wasn't necessarily over AI. I just wanted to do something different. I was just over the notion of using AI strictly within the confines of a web page or a terminal, because that's a lot of what we've seen in demos. That's a lot of what we still see today in demos when people talk about AI. So simply put, I needed a new interface for engaging with AI. So digging into my previous experience in the XR space, I figured that going virtual might be the next best step for me. And one day while sitting here at my desk, I got a message from a colleague inquiring if I wanted to collaborate with him on a talk that used virtual avatars and AI. And he had been experimenting with combining the two together, but he had some trouble given that he had a very strong AI background, but he didn't have a 3D web dev background. So I had the stronger background with 3D avatars and working with frameworks such as Babylon.js. So it seemed like a perfect fit. While we're brainstorming the title for the talk, he used a phrase that I had never heard before, and it was embodied AI. And that's when it hit me. I was like, embodied AI might be my next big thing. And I didn't want to just be limited to only doing things for 3D web-based experiences. I wanted to create for on device as well, something that you could hold in your hand, something that you can touch. And fortunately, have some friends over at Snap, and I connected with their spectacles team. I was able to get my hand on a pair of Snap spectacles, and I started to prototype some immersive experiences with the avatars that could hold conversations from you. So the ones that I have here on the screen was one that I had did some work with, and you were able to chat with her. I used AI voice from like 11 Labs as well. But, I still wasn't quite able to get exactly where I wanted to go in terms of just pushing my own personal needle forward on what I could do with AI. And I was still also riding that high of feeling like anything was possible after building my PC. So I thought it'd be cool to start exploring electronics. And I didn't know where to start. So I ended up purchasing a beginner Arduino kit that came with a very substantial instructional manual, and there was various modules available. And it was great to see things like this happen, whereas these LEDs can turn on when motion is detected. But everything in that kit was more or less plug and play, and there was no true hands-on building challenges. And that was honestly what I was looking for. Plus, not to mention, I don't like C++. I learned that very quickly. And so between the different programming language, but also learning a new UI for development, it was not on my list of priorities to learn those two things at the time. Of course, months later, I eventually learned that you could do things in VS Code for Arduino, but that wasn't information that I had possessed at the time. I knew, however, that Raspberry Pi was an option. And I felt like there was still a missing step somewhere before getting to that point of using a Raspberry Pi with different electronic components. But I also didn't want to purchase another electronics DIY starter kit. And so I watched a couple of different intro to electronics videos. I took a trip to Micro Center. I did a little Amazon shopping spree. And next thing you know, I had components. And the guys that I had met online in the electronic space, they were right. It was a lot cheaper to just buy components individually rather than purchasing pre-built modules and DIY kits. But I also soon learned that there's not much value in the components if you don't know what you're doing with them. So it was time for me to start learning how to build. And since I didn't quite know where to start. That's when I turned back to generative AI again to give me some guidance. And so rather than diving in, searching just miscellaneous topics, I went to ChatGPT and Claude and I asked both of them if they could provide a curriculum that I could follow. I don't have a formal computer science background, really any formal tech background. I have a business background and I used to work in luxury fashion. So I had been very removed from the tech and electronics space from an educational perspective. So a lot of figuring out how to move forward, I was able to leverage AI to help me with figuring out how all the pieces come together and figuring out what to learn. I asked both tools explicitly, though, to create curriculums because I also wanted to see where there were overlaps in topics and where there may have been some differences as well. So I can get a much more broad but put together image of like what I should learn. With the curriculum in hand, went over to YouTube, started watching videos. And this was a far better approach than what I initially was going to do, which was just picking random videos and random topics. I am a sequential learner, and that means I like to learn things in a structured order. If the YouTubers ever mentioned anything that just went over my head, I went straight to AI and I asked to break things down in a simpler explanation. And sometimes their simpler explanation wasn't simple enough. So I asked it to break it down just one more time. And I found that to be very helpful. When you're learning something new and you're not part of a certain area, sometimes like it's embarrassing to ask questions, especially when it seems you're in a room where everyone knows so much more than you do. And sometimes you're too shy to ask those questions. You don't want to feel like you're bothering someone. And that's why I've leaned a lot on using AI to help me with learning. And I feel like it's helped me grow quicker than had I had to stop and try to find people to give me answers. But that doesn't mean I took humans out of the equation throughout my entire journey, because there's definitely folks I've also leaned on for some help as well. But in these beginning stages, I would say it helped me because I didn't feel scared to learn. I knew I had something that I could rely on. So the first step after watching these videos, I would say, was to do something hands-on, because sometimes I can over-index on learning theory. And I spent a lot of time watching people do stuff, but I didn't physically do it, but I had the components. So I said, let me do the hello world of electronics, and figured out how to do a basic LED circuit. This video here is actually the very first LED circuit that I put together with a switch. And so I had to record it. I was excited for it. And I was very proud of myself. But that's what I really love about electronics, and just even the simplest things can really give you the confidence you need to do the next thing. At least for me, the things that now seem obviously simple, those were the things that gave me the stepping stone to keep going. And so then I kept going, and I got a little fancy and upgraded to parallel circuits. And so when I started figuring out how to do parallel circuits, I then also wanted to transfer what I had from my breadboard over to perf board, which meant I had to learn how to solder. Soldering is not my strong suit. I still struggle with it, but I did figure it out to an extent. And so once I got this working, of course, I wanted more. And I knew that I needed to do a little bit more because I saw more cool projects online. The algorithm's very funny like that. The more you start showing interest in one thing, it shows you more of it. And then I start seeing all these cool things that people are building, but it seemed like I was missing something somewhere. I also wanted to create the cool projects. And I also noticed people were creating PCBs, and I didn't know how someone took their idea that they had on a breadboard and put it into manufacturing a PCB. Plus, I also started looking at my own learning journey at this point, and I said, it would be great if at some point in life, I created my own getting started kits, because coming from someone that didn't go to school with this background and learning from the beginning of just trying to piece things together, I want to help fill that gap for someone in the future. But I knew I also needed PCBs to help support that. So I, in my head, gave myself the use case for learning how to create my own PCB. So started going down the rabbit hole of watching KiCad videos, and then I took on a new challenge. Well, roughly 2 weeks later, I received this package in the mail from China. Honestly, I'm sometimes still in disbelief that this was even possible because I managed to design my very first PCB. Now, the circuit's very simple. It's just a parallel LED circuit with a switch. And I would say as a whole, though, this was a really huge game changer for me, because now I felt like I could really do anything, because now I was holding something that I actually designed on my own. But I will say AI did help me in the process, because there were some moments where I would watch a video that may have been outdated on using KiCad. I know some folks call it KiCad. I still don't know the correct way to pronounce it, so I switch between the two. But while watching some of the videos, I would notice maybe the UI had been updated. And as I'm trying to figure out where something is, fortunately, whether I was using ChatGPT or Claude, it would point me in the direction of where to find something. So that was really helpful. But because these were being manufactured in China, I live in California, we have a 2 weeks period of getting this over to me. I didn't want to waste my time doing multiple iterations just to get one thing working. So before I submitted everything to JLC PCB, I actually posted a picture, a screenshot of the schematic online, and all the guys that look, and I say guys because most of this space, they're guys. All the guys that saw it, they chimed in, told me everything looked good. So I was very grateful for that. So I had the blessing of men who knew more than me. So I went on ahead and submitted it. And I will say it all worked out beautifully. As you can see in the video at the bottom, I did put one of the circuits together. It's lighting up. Tiny mistake that I made, the component for the battery is backwards, but it still works. So I was very happy that I was able to get that figured out. And so once I had this, I got a little ahead of myself. I grew a little too overconfident, as one usually does when they have a lot of success. And I thought to myself, I can make a robot from scratch. So I went from LED circuit to I'm gonna make a robot from scratch. And I started chatting a bit more with this time Claude in particular, to ask, like, what does it take to create a robot? And then I realized there were some huge gaps in my knowledge, and the gaps were wide enough to the point where I didn't feel that AI could fill those gaps for me. So I said, okay, come back down to earth a little bit. Let's just purchase a robot DIY kit. And that is where Pixel came in. So Pixel is a Pi Dog by Sunfounder. And when I opened this box for the very first time, there were a lot of metal pieces, there were a lot of screws, various components. They were all packaged very lovely together with a set of instructions. But this was, to me, a really big build, because before I was literally just putting stuff on a breadboard and calling it a day. But now I had something that was a little bigger. I also ended up choosing the Pi Dog because one, I could use a Raspberry Pi, which meant I could also use Python. I didn't want to try to figure programming out with C++. And so I was very glad that I was able to find this particular kit to help me with understanding, like, what does it take to bring together a robot? What are the different components that could go into creating a robot? I knew robots could be much simpler in form and in shape, but I decided to go with this Pi Dog because it's a bit more substantial in nature in terms of how it's put together. I knew it would give me an opportunity to learn more about some of the different components I can consider as well later in the future. In addition to that, this is also a kit that's not just random kit that apparently no one has ever heard about. The reason why that was important was because I was able to then leverage AI with troubleshooting any issues I had during setup as well, because the information was available online. And so by being able to leverage AI in that way, this also saved me a lot of time, because naturally when someone puts out a product, and if they usually link to a GitHub repo or some documentation for getting started, at some point that gets outdated, vendor doesn't update it. We all know that happens. So that is where then AI came in and helped me with getting through the challenges I had. There was some updates that needed to be made with just the setup process of installing the libraries. And I kept hitting some issues with my Raspberry Pi where things were just like stalling. And I was able to get through that. Took me about 30 minutes, but I was able to get through what was going on wrong with Claude. Pre-generative AI, my only available resources would have been either reaching out directly to the vendor, trying to figure out if anybody posted about it on Stack Overflow, or just randomly asking people on the internet, which would eventually get me to my answer, but it would take more time. And I really wanted to figure out, like, how do I move forward so I can start programming this robot dog? So I got through everything, got Pixel, who I've named him Pixel, good and ready to go. Pixel is, I told Pete earlier, Pixel's here. He sits on my desk, but I was able to get to a point where I was able to actually start programming. The programming part, I knew how to do that. I'm a programmer, but I wanted to start experimenting a little bit to see what AI could do if I combined some of the capabilities that I knew GitHub Copilot could do while programming Pixel. And what I really wanted to create was the ability for Pixel to detect my face and then do a greeting of some sort. So I created a very short script to do the face detection. And I wanted to put in the middle of the code some combination of movements for Pixel to move. Pixel, or the Pi Dog, if you will, has a series of different, I think it's like 8 servos. Don't know why I said 16, 8 servos total. And this was my first time working with servos, and not to mention using them in such a manner of moving a dog. Because I wanted Pixel to act like a dog, I couldn't comprehend in my head what is a dog-like movement to program with servos. And so fortunately, I knew that I could use GitHub Copilot to figure that out, but I was also curious to see like what it would come up with, because like as humans, we know how dogs move, but then does a language model know how to program servos to make something move like a dog? I didn't know. So I figured I would experiment with that. What I ended up doing was going to Sunfounder's documentation. I pulled everything in their servo section, including code samples, and I placed it all into a markdown file. And for the next 2 slides, it's a clip of what happened when I pulled all of that together. I hope the audio is playing. If not, do let me know, but I will proceed to that.
So figured it'd be helpful to give GitHub Copilot some context
Your
on
audio?
what constitutes a dog-like combination of servo movements. So I created this markdown file that contains example of, well, dog-like servo logic. And I have it organized by areas of the dog. So at the top, I have the legs. And then just below that, I have a section that's dedicated for the head. And then below at the very bottom, I have a section that's dedicated just for all the tail movements. Using GitHub Copilot, I'm going to ask it to add a custom sequence of dog-like behaviors to the greet.py file between Pixel's bark and his tail wag movement. What I've done here is open up the greet.py file so that way Copilot has it as context. And you'll notice that when I mention the servos.md file, I use the @ symbol. And what's that going to do is reference that servo markdown file that was created. So let's let this run and see what happens. Okay, so we have a response from GitHub Copilot. Let's see what it's done. So we can see its reasoning. It did go through that file, and then from there, it created the dog-like greeting sequence, and it chose to have it stand up excitedly, do a tilt head, nod, and then do a play bow. And so down below, I can see GitHub Copilot's explanation of what it's added into the code itself. And I think this is very interesting. Again, this is purely experimental, just giving GitHub Copilot context and seeing how it understands a dog's movement. All right, so let's see what GitHub Copilot came up with. All right, he seems to be looking for my face. And I can also try moving him a little. Okay, he saw it. Oh, so cute.
Simple in terms of what GitHub Copilot put together, but I was just, and then my real dog is now wants attention. I was just very, to me, I was just shocked at what it all had brought together in figuring out how to program the PyDog. And so as I moved forward with my next set of builds, I let my knowledge gap dictate what it is I wanted to explore creating next. And so the PyDog made me more curious about programming with servos because, again, like I said, that was the first time I had ever used servos. I still wanted to achieve that dream of building a robot on my own, so I knew I had to get comfortable with programming them. The top project that I have here is a sentiment analysis project that takes a string of text, it passes it to an LLM. The LLM assesses whether the statement is negative, neutral, or positive. If it's negative, the servo moves to the left, neutral the middle, positive to the right. And I also hadn't done anything with GPIO pins on a Raspberry Pi either to control LEDs. So I threw that into the project as well. If the sentiment was negative, we get a red glow, the red LED would glow, neutral, yellow, green, then it would be a positive. And this was also coming out of doing the PyDog. This was the first like build I did without formal instructions. And so of course I had to use AI to help me with figuring that out because it was a really big intro to GPIO pins. With the PyDog, it just told you where to plug things at. So it wasn't like I comprehended what I was doing. It wasn't until I started doing this particular project that I was able to understand. And I passed it off as building like useless things. And that's how I like framed it when I had posted it online, is that sometimes the useless builds are the things that helps you learn the most information, at least that way for me. And it did start to get me more comfortable with doing things with servos and GPIO pins as well. And so in general, the phrase like you don't know what you don't know is very much my North Star as I continue to build things. And I leverage generative AI a lot to help me figure out, well, what is it that I don't know when there's a certain project that I want to consider doing? I also leverage AI to help me with forming together ideas of a concept of a project as well. And it helps me identify some of the different components that I might need, some of the topics that I need to consider learning about as well. And I do supplement learning those topics by going to watch YouTube videos as well. YouTube has been like probably the second best resource I would say so far for me in this journey. Books as well. I am very much a physical book reader, so I have started purchasing some books to learn more as well. So I have quite a little combination of tools that I use as I'm building things. I also have been grateful in terms of using generative AI for filling gaps to help me identify when there are simpler ways to build things. So at the very bottom, there's a picture of this audio record. Well, I guess it's not an audio recording because it doesn't record the audio, but you can put an audio clip onto it and then press a button to play it. I had wanted to make this card for my husband for our anniversary that when you press the button, it plays me saying my wedding vows. And I learned just from chatting with, it might have been Claude or probably Claude, that mentioned that these modules already exist. You don't have to build everything from scratch. So again, that's you don't know what you don't know. And as someone who's very new to this space still, like I didn't realize things like this existed already put together. So I'm still very actively use AI in my learning to help guide the direction, to help identify what it is I need and like what I need to know, and also to help me with conceptualizing what it is that I'm building. But sometimes AI gets things wrong, and we definitely know this. It can definitely hallucinate. And so what I have here, I was recreating the Simon game. It obviously looks nothing like a Simon game, but in essence, this is Simon. And so I have the audio turned very low. Otherwise, we'd keep hearing beeps on this one. But I had really wanted to learn how to use LCD screens. I had never done a project with a screen before. And I quickly learned that not all screens are plug and play. There was quite a bit of setup to get this one working, but I got it working, as you can see. And also figuring out how to create these parallel circuits with a switch, but using the Raspberry Pi. The Raspberry Pi part was newer for me. I knew how to create the parallel circuits with the LEDs and the switches, just with the breadboard not connected to the Pi. But once we added the Pi component, my brain turned to mush and I didn't know what was going on. I thought I would cheat and use Claude and ChatGPT to help me figure out the circuit. I spent more time than I care to admit, only to find out that it kept telling me the wrong thing. And so that's when I learned that while LLMs are great for some things when it comes to electronics, designing circuits, it is not. so that is something that's still to be desired, believe it or not. When I finally said, you know what, I'm going to start over, figure it out on my own, it took me maybe only 20 minutes to figure it out. And that is why we still use our human brains when we're figuring out issues that we have. And I will definitely say it was a big learning moment for me not to over rely on AI all the time when it comes to actually figuring out how to build things, because we can think critically. And I dug into my internal knowledge base of things I had learned from videos here and there. And that's how I got to a point where I could get this working properly. So in terms of what's next for me, well, cyberdecks are really in right now. And so of course I want to build one. I feel left out. And so while it took me a while to figure out what I wanted to use my cyberdeck for, I ended up coming up with the idea of creating the Moonjoy A2. This image on the screen is just a prototype. Will the real version look like it? Maybe not an exact replica, but it will more or less hopefully look somewhat similar. What I wanted to do with the cyber deck was really lean into all the hype we have right now with the Artemis 2 mission as well, and put together something that would leverage some of NASA's APIs to just show some of the different images, some of the different audio clips, and then whatever else they have available. Now, I also wanted to lean more into creating this project because while I'm starting to get more comfortable with bringing together components and the programming side, I hadn't done really any real construction of anything. I wanted to actually start getting my hands a little dirty. So I have some 3D printers already, but I didn't want to use that to build this. I wanted to use acrylic. And I learned very quickly that not all laser cutter machines are the same. And because I was too good to use, I guess, just regular color acrylic, I wanted clear acrylic. That's when I learned I needed a CO2 laser cutter instead for that. And so I was very fortunate enough to find one under my $2,000 budget. Ended up getting the Flux BMO CO2 laser cutter and engraver, and it's huge, but it's like sitting behind me. But apparently it's huge, but it's small. It's a desktop laser cutter, and I'll get a chance to figure out just how to go about creating everything I need with acrylic. Because I have the XR background, I know how to 3D model already. So I know how to design things, but now it's more than just designing, it's also making sure the measurements are right. And because I want a cyber deck that opens and closes, now I got to bring in things like hinges that I can now add to this build. And that's when I ended up learning that I need to use, I forgot what they're called. I'm sure you guys know, they're the little like things you got to inset in so that way you can screw. And I'm doing the worst job at describing it. But all that I learned by chatting with AI as well. This is where I still am using AI to fill gaps and understanding what things are called and when things are used and how does this work? How does that work? And I'm very excited for this build. I'm hoping to have it completed within a month, and I'll be more than happy to share more about that. I also wanted to create a keyboard, never made a keyboard in my whole life. So I added a macro pad as well to this build. So I'll be building that. Went down a very dangerous rabbit hole the other day of how to create a PCB for a macro pad. So that'll be a separate build one day. But for this one, I bought something that already had the PCB created. Now I just got to put the switches and keycaps on. So as a whole, I would say this is next project, still leveraging AI to help me figure out what all comes together because I didn't know what to buy. And I was able to create a shopping list, needed less than what I thought because I had a lot of things already. And I'm really looking forward to doing this build. So as a whole, I would say I'm still learning. It's been a lot of fun. I'm really enjoying venturing into this side. I'm so glad that I stopped telling myself that I couldn't do electronics. I could never understand hardware because I've been having a lot of fun. I mean, look at me smiling, soldering, even though I'm not good at it. So I'm very excited to keep going as well. And I would say as a whole, first and foremost, thank you for listening to me chat more about just my journey and how I've been able to use AI. And hopefully it inspires also folks, especially those who are newer, to give electronics a try. Even if you don't know where to start, there's a lot of resources that are out there and available now. And aside from just using AI, meet other makers, meet other tinkerers. Actual humans are very, very helpful, not just from asking questions, but just performing relationships with. And I found just the community as a whole to be very welcoming, very nice, very creative. I'm always in awe when I see what people are building. And yeah, if you ever want to stay in contact, Pretty Wired Builds is my name on Threads as well as Instagram. And then my website, Pretty Wired Builds as well, is where you can, within the next, hopefully 2 months or so, start seeing more details about the builds that I'm doing. I'm in the midst of revising what's happening on there. And thank you for listening. I appreciate it.
That's so
Yay.
good. Absolutely
Yeah.
love that. Brilliant.
Thank you.
Awesome.
Love the passion. Just that all on its own to see how the journey and how much you were enjoying all of the learning that went along with that. It's fantastic. Really cool to go from the hello world, quite rightly, time to flash, all the way through to making PCVs and dogs and now cyberdecks. Is really cool.
Yes, thank you. Yeah, and I would say sharing what I'm doing has been helpful because I'm there's that fear that comes with sharing what you're building when you're new, because you see so many people that have just years of experience sharing the projects that they're making. And to me, it's very inspirational to see that, but it's also can be very intimidating. But I found that just sharing what I'm doing online has been great. This kind of leads into Cliff's talk, but someone had commented on one of my Instagram posts and it was like a Raspberry Pi post, and they were just like, have you tried ESP32s yet? And I'm like, no, I don't know what that is. And so I went to Micro Center on last week and I actually like bought some. So that's like next project is to figure out what to do with these. I spent like an hour watching some videos while I was doing my hair the other day. So I'm excited to dive into that, but I'm also excited for Cliff's talk because of that. So yeah.
Yeah, well, when you do, and Cliff will probably mention it here, definitely take a look at .NET Nano Framework.
Yeah,
So I've
very
mentioned the book in the chat. So another MVP, a really good friend of ours, Jose Samoes, has written this. He created Nano Framework, and there are a few folks at Microsoft. Lauren Ellerback, you may know, is one of the maintainers of that as well. So that'll let you do C# on ESP32, which is way better than trying to do C++. You are 100% correct. That's one of the things that puts people off more than anything. So Tinkercad, I found as a good way of not doing C++ as well. If you played with Tinkercad, then
Ooh, okay.
it's fantastic because you can actually do it in a Scratch-like drag and drop blocks and program your device that way as well. So that's another good way of getting around not having to do C++. Couldn't
All
agree
right,
more.
I will take that down in my notes. Thank you very much. And yes, I saw your comment, threaded heated inserts. Yes, I had to
Yes.
purchase some of those. And I've been walking a very fine line of functionality and aesthetics because the build I want to be all clear acrylic with just gold. And so just like trying to find, I'm trying to make hardware work for me versus the other way around. So it's been a journey, I would say.
I love it.
The other thing I put in the chat, instead of waiting 2 weeks for your boards, Osh Park, which is an American
Okay.
company, make I like Osh Park because their boards are purple rather than that cruddy green. I haven't got one in front of me. Pete will have
I
one
have.
because he
Yeah.
likes them as well.
Yeah.
They're very, I think they're really, really pretty boards. Just the way they do the screening and everything else as well. But yeah, that could be something. You'll get them quicker, and plus, I personally think they're prettier.
Thank you. I appreciate that.
Osh Park. I can't remember where they are in the States now. Whereabouts are they, Pete?
I've got a feeling it's Arizona, but I could be wrong.
Yeah. But yeah, it's like kind of almost kind of .NET purple, isn't it?
It's that colour. But that
Yeah,
was
it's like a
kind
deep
of black, but it's a dark purple. It's beautiful.
dark purple. Yeah.
So I've been doing it for years, but actually in modern times, I'd not created a PCB either. So I'd created PCB since I was 19, but using really old DOS programs and etching them myself and doing all of that. But I got out of that for a good long time and then wanted to learn how to do it in a modern way. And I did the almost exact same thing as you, KiCad. And it's KiCad
Yeah.
for me as well, by the way. And I wanted to create this Steam Deck type idea. So I created my own one using a Raspberry Pi Pico. And part of that journey was specifically so I could go create a PCB, and I soldered it live online, and a bunch of people watched me make a bad job of soldering. Soldering's hard, generally. I don't think there's very many very good people, and I've been soldering all my life, and I'm still not all that good at soldering. So having a good, you've got a good soldering iron as well, which helps. I think probably I should just invest in a better soldering iron.
That's the biggest problem. Having a decent soldering iron
makes a big difference. Yeah, that was one thing that I relied on other people to advise me on. Anytime I don't know, like if I can't figure it out with AI, I had right on the threads and I just asked all the people on there to recommend stuff. And I do further research, but yeah, soldering iron, that was that. I remember when I had that conversation online with some folks. And so I'm glad that I got what seems to be a good one. So
yeah, that Weller one's good for sure. Yeah, definitely. Loved that. That was fantastic, and I'm really looking forward to seeing where the Cyberdeck goes and what you make there. And do you find that your fashion background has that played a part in how you go about? Yeah,
it will be because I bought a book on wearable electronics because I do want to get more into that particular space. And once I get past the Cyberdeck, I will be doing some more things in the wearable electronics side. And I have an unfinished skirt that's like sitting in my corner that's not in view right now that I might add something to, might do something with the jacket as well. But I want to do more than just glowing LEDs. And that's my challenge because a lot of the examples I see is that, and I want some more functionality. So I've been spending some time brainstorming on what's possible. And I think over the next month, by the time I get done with the Cyberdeck, hopefully I'll have a good idea of what it is I want to try to create. And we'll see. So yeah.
Lady Ada and Adafruit do some awesome wearable tech. I don't know if you found their website.
I have a package from them.
Yeah, I've got lots of boxes from Adafruit. But yeah, they make some awesome kit, certainly for wearable stuff as well.
Yes. I got ahead of myself and ordered some things. And then when I started reading a book on wearable electronics, I was like, oh, I'm missing some stuff. So now I have to do another order for some of what Adafruit has. So yeah, but I'm always open to recommendations. I'm always open to people sharing resources. Like I said, you're talking to someone that's very new here still. And so there are things that I definitely still don't know in terms of resources available. I'm just grateful for all the knowledge that people give me.
Wait, April,
Yeah.
the book that you're reading in regards to wearable electronics, is it
I
by
can drop a
Kate
link in the
Hardman?
chat. Yes,
Okay.
that name sounds familiar. Let me make sure. Let me go on my Amazon just to
Is it
make
part of the
sure.
Make series?
Yes, it is part of the Make
Okay,
series.
okay,
Yeah.
that's cool. Yeah, I like that book.
Yep.
I actually
Yep.
had 3 questions to ask you. But first of all, I want to thank you for your time as well and for the content you've done. Because, like you said, when people are sharing their experiences and the building journey, it helps other people like get a visual guide and that human connectivity. Because I use AI as well. So, what I wanted to ask in regards to that is, what kind of safety guardrails do you put into place with your AI, or do you not put any in? And do you run any local models or host any locally?
Yeah, so I think for right now, where I'm at in my current process for doing anything with electronics, I don't have any specific safety guardrails in place purely because the way I've been using AI as of late for like when I build Pixel was like create dog movements. So for something like that, I haven't had a need to have any particular guardrails. However, as things continue to scale in terms of ways that I'm using it, if it ever gets to a point where I need AI to generate responses for something that maybe the responses aren't necessarily always going to be responses for me, but just for like everyday people, there's things like at Microsoft, we have like our content safety filters that you can integrate into whatever you're building, and it'll detect whether the generated output or input from the human actually triggers any of our content filters around anything that's violent, sexual, harmful, or I think hateful. I might be missing a category. So something like that's really helpful because it helps mitigate getting that dangerous output or getting something dangerous input wise coming in. With respect to local models, that's also another reason why I actually started with using Raspberry Pi 5, because at the time I just kept hearing that you can put a local model on it. And I gave that a try, but with the I think there's something newer that's out now, but at the time when I was trying it, just the speed of generating the output was just incredibly slow. So I didn't try more with it. But I did see a guy post a video recently on YouTube with something that had came out recently. I think it's like retails at like $299. That if the time comes, I might give it a try and see what I can do with it. But right now, I'm not dying to try it. I would say I have quite a backlog of projects that I'm working on. But hopefully at some point, I'll give it a try. I had actually, when I was brainstorming cyberdeck ideas, one of the ideas I was going to do was going to be like a plant classification cyberdeck, if you will. And I was going to do the classification ideally with a local model, but then the Artemis 2 mission happened, and that just like took over everything in my brain. So I ended up changing. But there's always time and space, no pun intended, but there's always time and space to give it a try. So hopefully, ideally one day. But yeah, with using just guardrails though in general, with AI, I don't pass any of like my own personal information, but when it comes to like generating output, depending on what the build is, that's where I might start to leverage more of like our content safety filters that we have.
Okay, thank you for that. I love Pixel, by the way.
Thank you.
I love the content whenever you do it with him. Like I saw when you were teaching him and giving him treats, like how to respond to touch as well. I love that as well.
Thank you.
Awesome stuff. Great stuff. I mentioned in the chat Alex Glow, not quite sure how you pronounce her last name there. She does some awesome stuff in this space as well, including some wearable tech.
Perfect.
Checking that out.
Yeah, she made this owl familiar that she wore essentially. It was awesome, and a fox as well. It's
a fox.
Cool. Yeah.
Yeah.
Really cool. Yeah,
Oh,
well worth
perfect.
following along with some of the stuff that, and I think likely her journey would have been similar to yours. I think a lot of people in the IoT space actually are really interested and end up being self-taught. It's why I love it
Yeah.
so much because it's accessible and physical computing is it just makes what we do real rather than it just being an input prompt and you know.
Just software.
Another form
Yeah.
over data.
Yeah,
Mm.
yeah. So long as it's
Yeah.
just not getting stuck at a BME 280. Hey.
No, no.
Good. Right. Does anybody need?
I'm quite impressed though that Jose used the BME 280 because they're everywhere, but he decided not to do temperature and humidity. He did temperature and relative
Pressure.
pressure,
Yeah.
which I thought was quite nice. That he thought of me at that moment when he was writing the book.
Yeah,
So,
Cliff and I have both got a problem with every IoT tutorial ever made. Is you're right. You start with an LED and then a button, and then it's a temperature and humidity sensor, and then everyone stops because it's
yeah,
boring. Whereas the stuff that you're talking about is definitely the way that Cliff and I
awesome.
want folks to learn IoT. It's just skip that part and start building stuff.
Yeah.
Yeah.
Right, I need to go top my water up. Does anybody else need a quick break for just a couple of minutes, and then we'll get going
Yep.
with Cliff's talk. So if we carry on in just a couple of minutes, then that should give folks enough time to.
Be right back
sort
myself.
themselves out.
Yep.
Yeah, be back in
Cool.
just a sec. Feel free to stick around and talk if you don't want to do that. It's perfectly fine. But I'm going to mute and go off camera for a minute. And back in the room, quite literally.
That was.
And no worries, April. All good. Deserved. We'll just give it another minute and just make sure that everybody else is back before we get going with your part, Cliff. But thanks so much to April for that talk. That was awesome.
Yeah, I really enjoyed that.
Definitely going to be keeping an eye on some of the rest of the journey that you go through there. It's fascinating to see all that coming together. It's awesome stuff. So I don't know if Andy, Ricky, and Larry are back yet, but so we'll give it a minute or so and then get going.
I've shared my slides. Are they viewable?
Oh yes, I see that.
Right. Okay. Cool. I'm not sure if they were or not.
What are you looking at? You know, the number of times I've copy and pasted that profile photo of you. What are you? That's it. Nottingham. That's it. The Nottingham.
That's the DDD knots.
Yeah.
I'm looking up at the screen, and it was their photographer on the day took the picture, and I thought it was quite good, so
Yeah.
I use it.
Yeah.
So
It is.
yeah.
Got Maui t-shirt on.
Got my Maui t-shirt on. Yeah. I'm wearing an aviation theme one today. Sling aircraft.
Nice. Well, that's the one you're building, yeah.
Yeah, I've had to decamp into the office in the house, which my wife normally uses, because the computer in the workshop wasn't playing ball. It wasn't happy. So I've moved in here because I know my laptop works, but I couldn't use my laptop out there because it would have been cables and plugs and all sorts, and there was no charger out there for it. So in a panic, I moved in here. So I don't know why it wasn't working though. It's Visual Studio just kept saying that it couldn't run an Azure function. It was like
weird.
you don't have an Azure function runner. I was like, well, you run one the other day, and all it had done is updated itself. So obviously, the new update decided to break things.
Wonderful,
Hey,
wonderful. And April says you look like a visionary in that photo, which I kind of agree with. To be fair, it's a good photo.
Yeah, visionary of what?
We're about to find out.
Yeah.
Cool. All right. Well, with that, I will pass it over to Cliff to talk about using an ESP32 and .NET Nano framework. Oh, you know, Jose's going to be angry. Oh.
Well, it's got a capital N. Darn it.
That's like doing GitHub Copilot and putting a capital P in the middle that people do. Oh,
yeah, that's my bad. Yeah, it should be spelt like that up the top. It should be like that up the top there.
Yeah.
So yeah, like that. Not the capital N, but hey ho.
Anyway, with that aside, I'll pass it over to Cliff. Thanks very much.
Oh,
by the way, I didn't even ask you, Cliff. Are you all right for folks to just come off mute and ask you questions as you go, or do you want
yeah? If they've got questions as we go along, I've got a few slides, and then we'll jump into Visual Studio and just kind of move around the project and then out onto the Azure portal. But yeah, feel free if you've got a question, come off mute or chat it, drop it in the chat, and I'm sure Pete will ask it. If you're not comfortable coming off mute, that's fine. So yeah, my name's Cliff Aegis. I'm a .NET developer, Microsoft MVP for developer technologies, which is .NET basically. I do a lot of .NET Maui stuff and projects. I do a lot of IoT. I was an IoT MVP last year, but for some reason lost it. It looked like they was closing it down for a wee while, but they've kept it going, which is fantastic. When I'm not working on software and in development, I'm a commercial pilot and fly around Europe in Airbus A320s. I mentioned that purely because it links into what we're about to talk about securing aircraft. So you see my LinkedIn QR code there. If you want to reach out and LinkedIn with me, that's fine. Happy to share these slides with Pete afterwards if they want to put them anywhere. So I'm going to talk about Nano Framework, but let's get on the right screen, Cliff. Let's talk about what I'm trying to secure. So when you become a commercial pilot, you have to start off in the smaller planes and the little aircraft that are used to train pilots, from someone that has never flown a plane before all the way up to the commercial aircraft that I've flown around Europe and the world. But there's been a bit of a kind of epidemic of the aircraft engines being stolen, certainly the Rotax ones, as you can see in the image here. It started back in around kind of 2015-ish, 2016, and it's still going strong now with these aircraft having their engines stolen. And these engines cost 30 to 50,000 each. They're not cheap bits of kit. They're also, the supply is quite restricted because of the components are in there and yada yada. You get the point that but More kind of upsetting for me and fellow pilots is the fact that aircraft is now grounded, and depending on how they've removed the engine, it could also mean that the aircraft is scrapped, and that's another aircraft that the engine 30 to 50,000, the aircraft is around 250,000. So it's a lot of aircraft, a lot of money that's been lost because someone wants an engine that is a road tax engine. The reason I want these, you can see here where they've taken it off and just ripped it off and cut it. You can see up the top, just here, you can see where they've just taken a saw or a grinder or something and cut straight through the lugs that hold the engine on. And again, there's another one just there as well. So a lot of damage to this aircraft, which then subsequently got scrapped. So the owner was pretty upset. You can see here that it's just in a metal hanger on an airfield. So yeah, there's over 130. I found this earlier on today. Between 2020, 2000 and 2021, there's over 130 engines that have been stolen and climbing quite quickly recently, and that they're all across the world. You can see there, from Germany, United Kingdom, France, even Russia and UK, and the US and the like. So there's quite a lot of engines being stolen, all, as I say, 30 to 50,000 each. So you can add up and do the math yourself. So it's quite expensive. But where they're being used? Well, it turns out that quite a lot of them actually are being used in drones, and drones where kind of the country, in this case Iran, is struggling to purchase components because of the restrictions placed on them for purchasing components from around the world. So it looks like they're being stolen to order, because they're stealing two specific types of the road tax engine, 914 and the 912. Are being stolen, and they're turning up and appearing on battlefields, which is even more upsetting, because not only are these engines being stolen and aircraft are then being technically destroyed, but they're being used to actually do harm to others, which, as I'm sure it does you, it just galls me that these are being used in this way. And the number of engines being stolen is ever increasing. So I thought to myself, what can we do about this? So I thought, well, we could use some IoT. So, well, back in the day, we used to use these. I deleted these slides earlier, but they've appeared, so I'm going to skip through them. We could use an Arduino and pick out and use those to build something to protect these aircraft and find out if there's a bad person there. But Arduinos are good, but it didn't quite have what I needed, which was a camera and the lights. Because what I wanted to do, if I go back to the slide with the hangar, is you can see this hangar is in the middle of a big field. There's no Wi-Fi around, so you can't connect to Wi-Fi. And those airfields that do have Wi-Fi, they put up Ring doorbells in the hangars. But all the thieves did was work out that, well, they've got a Ring doorbell. Ring doorbells are really easy to block. All you do is block the Wi-Fi. You can buy a Wi-Fi blocker off of the internet for £20 or £30 off eBay, or build your own if you're into IoT. And then you're just blocking that signal, which means it's not going to work. So you can get in there with a Wi-Fi blocker on, take your time, and cut the parts off. They can use grinding equipment, because obviously it's in the middle of a big farmer's field, and run off with whatever they want. So there wasn't a device that a lot of people could find that would send the data via a signal such as LTE or your mobile phone signal, or via LoRaWAN, and connect it back to an office where there is a Wi-Fi signal and a stronger wired signal. So Arduino didn't quite cut it for me, mainly because, just like you, April, I'm not a fan of writing C++ or Arduino C. It drives me nuts and gives me googly eyes. So that was out, and I'm a C#.NET developer, so I thought to myself, well, we'll use that. And as we alluded to earlier, .NET runs everywhere, because this man said so back in 2021. And I looked at the Raspberry Pi. And Pete, I need to update that, because it says .NET 7 at the bottom, so it's obviously the slides I copied and pasted it. It's obviously a few talks out of date. But you can use Raspberry Pi. You can run .NET on there, and that'd be great. The reason I didn't pick a Raspberry Pi is because if you've ever used a Raspberry Pi, you know it comes with a big power brick, which then means you need 240 volts. And it's not a small amount of 240 volts. They're kind of 5-ish amps these days, the current ones, to do all the things they're doing. So that was out because we want to run this in a hangar that typically doesn't have any electricity. So we wanted to be certain that we could run this somewhere where we can do it battery or solar. So the Raspberry Pi was out. Sorry, Pete, we're not going to be installing your Raspberry Pi scripts. But it did mean that we could get into writing our language with .NET. So the next step was obviously looking at Nano Framework. And as we alluded to earlier, our friend Jose Simões has kind of managed this project and looks after it, written an awesome book. The docs are really good as well. But the good thing about Nano Framework, as you can see there in the left-hand side, is there's these cool little devices here. I'll circle them. I'm not using my, oh man, come on. Cool little devices here, the ESP32 CAM. So I have a little camera on them, as you can see there, which is a HD camera. So it does sort of 1080p images, which is really cool. And it has an SD card slot on the back, so you can store the data there. And using Nano Framework, it means that we can then write the files and the program in C# and .NET, which is awesome. And even just recently, all the generics have been added to Nano Framework, and you can now use generics. So you've got all your lists and stuff like that you can put in there. And there's other cool stuff that Jose was telling me that a few days ago that is in the pipeline, hopefully going to drop in next month or two. Which is going to make this project, even more compelling for your commercial offerings if you're writing software and IoT projects that you're selling on to customers. So ESP32 CAM, I sort of bought them off Amazon. They're dirt cheap. You can pick like a pack of 2 up for maybe £10-15. Not a lot at all. You can get cheaper ones from Alibaba and places like that off the internet. I found the cheap ones tend to be, you get what you pay for. They're cheap and nasty. You can see here in the boards that the actual board is just that top bit. This bottom part that it's sitting on is just a board that allows you to have a USB port for programming, and it's got the reset and boot buttons as well, or sort of program buttons on them, and it's got a couple of little LEDs on there as well, which you can use. You don't need those. You can get it without. I buy it with. It's a couple of pounds extra, but it means you don't need then a breadboard. You don't need to then keep moving wires around and need a special little program, etc. So for I've bought them with these boards, and I've got a few of those now, and then I just buy them without, because I can then just plug them into the boards, the little programming boards that I've already got. But they're well worth getting. They're awesome bits of kit, and they're super cheap, and they run really well. Problem was that Nano Framework didn't have a camera library. So this project has been in my head for the last few years. It didn't have a camera library. And it was always one of those things I was going to get around to doing and helping Jose and the team. And then Alan, who's another IoT friend of ours from South Africa, needed it for a project he was working on. And need it for a project he teaches students. So he went and took the time, took him a wee bit of time, but he wrote a camera library that works on the ESP32 CAM, specifically that board, specifically a variant of that board, and he made that firmware available on his GitHub. So I tried it out, and it works really well. It's a little bit dated, so it hasn't got some of the newer stuff that Nano Framework has got, and that's because he's pinned it to a certain build of the firmware for the ESP32. But it's a great starting point, and now that I've gotten into this project and see where we can go with it, it means that I'm going to work with Alan and Jose over the next month or so, and we're going to bring that up to date so that it works on the other boards, like the large board in the middle, S3s, and also come across. You can see I've got a Raspberry Pi Pico down there. That's part of the Nano Framework family. So it could potentially work on that, and then you can just wire in a normal OVO camera to use with the boards as well. So we're going to see if we can port it to as many of the boards as possible. So, but let's look into how Nano Framework works. You know, this is the stack. You got your hardware at the bottom. On top of that is the abstraction layer, the HAL as they call it, and then you got your platform specific stuff, and then on top of that sits the common language runtime. That CLR is a bespoke version that's written by the Nano Framework team. Then sits on top of that MS Core Lib, but it's not the MS Core Lib that you know and love from your .NET projects. It's a version that's built for Nano Framework. So when you go into the NuGet packages, if you type in Nano Framework then you'll see the massive long list of libraries they've got. You go out to their GitHub, you see all of those. So when you're putting in a library, like if you want to bring in MS Core Lib, or you want to bring in one of the security libraries, a cryptographic library, you always need to make sure in your NuGet you're searching Nano Framework and then find the library you need. Otherwise, it will bring in because you've written a .NET program, Visual Studio doesn't know. It will try and bring in the library for security or cryptography, get my words out, and it won't work. And your build will fail, and you'll be sitting there wondering why. Obviously, Ghetto Copilot, if you use that in your Visual Studio or VS Code, that's going to suggest the wrong libraries as well quite often. You know, I've been working on this project kind of last few weeks, and it's suggesting kind of things that don't work. But because of my knowledge of using Nano Framework, it's like that's not going to work, and you need to do that. And then the last bit about Nano Framework, and I'll show you when we go to Visual Studios, you need to be careful about the checksums need to match. So if you use an MS Core Lib, that's the core of your program, and where all your bases are, like your int and your string and your bool, etc. If you put a library on top that references a newer version or an older version of the MS Core Lib, it may not work, and you'll get build errors. So I'll show you those checksums when we go through it. But you know, you basically write your code. Your bit is just a green box. You write just normal .NET C# code. And you know, there's a couple of bits that are still missing, and Josie and the team are working hard at solving those. Like I say, generics come in very recently, which is awesome. But you don't have a lot of memory on these devices. So what you need to be careful of is you don't want to bring in too many libraries. So if you don't need a certain library, or if you can do it without needing generics, then go that route, because it means you don't need to bring in a generics library, which is only a few kilobytes, but it all adds up and builds up and fills up your memory that you have on your device. Looking forward to how a board is. These expressive boards and the ESP32 are awesome. They've got, when you look at the board, it doesn't have a lot of I/O or GPIO, should I say? But you can see it's got, you know, analog digital converters. It's got, you know, SPI buses. It's got a touch interface. It's got all sorts on there that you can use. And you know, the ESP32 board has got other parts on it as well for the camera and the SD card. So you can see there's quite a lot on these boards. And as I say, they're super cheap. These ESP32 rooms are even cheaper than the camera boards, and they're like buying kind of candy. You just kind of buy a bag of them and use them on various projects. I've got them doing all sorts out in my workshop, and you know, they're great. And pair it with Nano Framework, and you're into an awesome time having fun. Not just blinking LEDs and things like this, but you can connect it up and run the likes of, I would reach down and pull out a hand. If you've seen my talks before, I've built a prosthetic hand. You know, you can use an ESP32 in there with .NET code and run all your projects off of that, which is something I'm working on now. Handy V2, which will be a talk coming this way very soon, hopefully. But let's get across to Visual Studio and look here. So you can see on this project up here, I've just got plane protect is what I've called it, just for fun, because we want to protect the planes. And I've got an Azure function as well, which is sitting down here. You can see it looks like a normal .NET project. There's no difference between this and any other. And if we go across to the go across to the program.cs. In normal public class, we've got a normally kind of statics. We've got a normal public void main, so it looks just like it would if it was a command line program. You got your debug write lines. You can write test suites for it as well. I tend not to pull those in because I find that the bits that go into it are just using even microscopic amounts of memory. I'm sort of going back to that slide that I showed earlier that showed the microchips that we used to use back in the day. You was always fighting and bit banging the memory just so that you can squeeze every last bit out of your program. But this is all done for you. If you want to set up an LED board, an LED, you set up a GPIO controller just like you would pretty much in Arduino as well. They kind of followed that paradigm, and the IoT SDK that was released by Microsoft. But I think, correct me if I'm wrong, Pete, I think that's now kind of sunset. I don't think it's being used anymore.
The IoT SDK,
maintained.
no, it's still being supported.
Is it still being supported? I thought they'd sunset it. Okay.
No, they've made some mistakes. There's two board numbering schemes for the Raspberry Pi. There's a pin numbering and a BCM numbering scheme.
There is,
and they've got rid of the pin numbering scheme, which I think is bonkers. Never mind. That's another subject for another day.
Yeah. You see here, if you want to, the flash on the ESP32 has got a little flash because obviously you've got a camera. You need to have a flash. So the flash LED is on pin 4.
Zoom in a bit. Zoom in a bit.
I can.
Yep.
I can.
Or,
There you go. How about that?
No, a bit more.
Bit more. You want to go one more? Yeah.
Yeah. That's it. That's better.
Yeah. All right. Cool. So you got the flash LED is on pin 4 and it's output mode. There's an activity LED on the board as well, but oddly it's inverted. It's the other way around. So you set it to load to turn the LED on, just because of the way it works. So and that's on pin 33, and that's a little red LED that's underneath the board. I use that to tell me if the red LED is on, to tell me that the program's in setup mode, and then you got an SD card, so you can initialize the SD card and then get all the settings. So I store all the settings for the Azure connection for Azure IoT Hub are all stored in the SD card in the settings file, which then means that I just kind of pop the SD card in and I don't have any secrets in my code. So I quite happily commit this to a GitHub repo and share it, and not worry about the fact that my secret keys are out there and leaking around. And then we just check the SD cards loaded, and we load the cert. One of the problems with the firmware that Alan built was the fact that because it was built on a slightly older version of the Nano framework build pipeline, the cert loading function you can put into, if I open it up on the Device Explorer, and so you install a library called Nano Framework. In fact, let me show you how that's done. So you go to extensions, manage extensions, and Nano Framework to install the library, and then it allows you to create a new project with Nano Framework, which is great. And then what it also does is in the view, if I do this with other windows, you get this Device Explorer, and when you open that, you get this Device Explorer here, which gives you fantastic links. I thought this was awesome idea out to the API reference and stuff. And I use these links all the time because it's quicker than my fat fingers typing into Edge. You get a list if you got a device connected. So I've got a device connected at the moment on COM5, and then you can do things like kind of ask it things like the board stats and stuff like that. But you can also edit a network configuration, and that opens here. You can set the IP addresses you want to connect it to someone. You can connect it to Wi-Fi and give it a Wi-Fi profile. This Wi-Fi data I'm reading from SD card, and that's why it's in there. And you can also load the root and device certificates when you connect into IoT Hub or up to Azure. The problem is the version of the library that the firmware Alan did broke this bit, which is one of the things we want to fix. This has all happened in the last couple of weeks, so we found these bugs. reported back to him. I think he pushed an update this morning. I just wasn't brave enough to try it for this talk. So that's where you can set simple things like your Wi-Fi and that. But as I say, I'm reading it from the settings on my SD card so that I can change it as I need. And the reason is I go to a conference and give this talk there. I want to be able to set it to the conference settings there, and I don't have to go in and change those settings. So I'll just have it on the SD card and change it out. If it doesn't succeed, then we stop there, because if we don't have the data or the settings, there's no point going any further. We connect to the Wi-Fi, and this will be on the debug right line. And then what we try to do is set the date time. And the reason we want to do that is if you're going to communicate with Azure and Azure IoT Hub, etc., it's all going to be over TLS and 1.2. And for that TLS to work, you need the correct date and time. These boards, unlike your computer, don't have a real-time clock on them. So you connect to Wi-Fi, and then I just got a little loop there that tries to get the date time setting, which will come from the Wi-Fi host on the ESP32, and it will set the accurate date and time for you. So once that's done, and I've got a year that's above 2020, then I know that it's going to work and I can go through. And then, like I said at the top, I then turn the activity LED off and put it to low, which then means that I've then got an LED. So then my little setup has finished running. Then what we do is we connect to MQTT, which is a messaging pub sub communications protocol, which allows us to send messages to and from IoT Hub. And then I have a file upload service which sends the images up to IoT Hub. And once that's initialized and we have those and we've connected to IoT Hub, it's then basically into making an instance of a camera and then setting the frame size. At the moment, we could go to SXGA, which is the 1280 by 1024, and if that doesn't work, then we drop down to SVGA, which is 800 by 600. The SXGA sort of works, and the reason, again, you're being very careful with the amount of memory you're using is the device only has a certain amount of RAM. If you're taking a very large image like this one, then it needs that RAM to process it. But your RAM is also storing and running your program, your .NET program, your MS Core Lib, and your camera libraries, etc. So you're being very careful about how you manage that memory. So in here, I've been playing. It sort of works majority of the time with setting an image at that size. If not, then it drops down to a smaller image size, and which is 800 by 600, and tries there. And then if it can't get that, then I've just got to debug right lining out. Just for me, writing out what pins everything's connected to make sure I don't have something misconnected. Then lastly, once it's done that, it goes through, does it 5 times, uploads it to IoT Hub, and then I've got a power manager. And the idea of the power manager, here we go across the power manager here, is to basically put the device to sleep. I've got it commented out here at the moment. I just get it to sleep for 10 seconds. Sorry, it's 30 seconds on the SD card, or 30 times the 1,000, so it's 30 seconds. And then it reboots the device here. I don't put it into a deep sleep purely because I'm debugging, and I don't want it to go into a deep sleep while I'm debugging and looking what it's doing. But I do want it to reboot the device so that it then goes back to the top of the program and starts running it all again. So this here is a great way of setting it up and putting it in deep sleep. The advantage of a deep sleep is I can take a picture and send it up to cloud, go to sleep for maybe 30 seconds, maybe 5 minutes, and because I'm running on solar or a small battery, and then wake up a set time later and take another picture. And if there's a baddie there, doing something, it's going to take them more than 30 seconds or 2 minutes or 5 minutes, whatever time the person that's installing this is got it set for, and then they can set that time and decide how often they want to send the data to the cloud. So you put it to a deep sleep, it's going to go, rather than rebooting the device, it will just go into a very low level of power requirements, which means, I've looked at this, and ESP32 in deep sleep mode, waking up, connecting to an LTE device, send the data via mobile phone signal or LoRaWAN. It will probably run quite happily with a solar panel and a battery-backed battery for overnight use. It will probably run for months, if not years. So it's, you can get it down to that low level of power. So that's what we do there. The file upload service is literally, we get our certs that we stored on the SD card, and then we're uploading the bytes, and we put them in. We upload it to the Azure IoT Hub via the file upload. So it sends it up to IoT Hub. So it requests from IoT Hub, in the connection that we've already created, it requests the upload URI. And from that, it then sends that data up to that URI, which is then a storage container where those images are stored. It then creates a blob of the image and uses that to file upload that uploads that image up into Azure file storage. And then once it's done that, and we've sent the file up to the cloud, you then need to notify Azure IoT Hub that the upload is complete. Otherwise, it gets a little bit upset that you've hung on to this file upload. So you tell it that it's complete, and it tracks it, and it stores the event in the device twin as well. So you can store this correlation ID, and everything else is all stored into your IoT device. And you can see I've got some little helpers here. The MQT service, I'm not really doing much with it. All I'm doing is connecting and saying like hello there, and I'm also connecting up an event which is a cloud to device message. So when the cloud to device message is received by the device, I'm just getting it to do the flash, and then I'm turning on flash command, which is basically just turning on the flashlight on the front of the board. And you can see down here, we're subscribing, and we set the device ID, because there may be more than one device, and we connect out there, and then publish that MQTT broker out to the device. So it's all fairly straightforward and simple. So what we've got now is an ESP32 that, if I click run, I've got my little ESP32 here in my hand, and you'll see it will start to build. Make sure it's in the right project. It is. It's on Nano Framework. So do this. You can see it's all deploying down here. And if we go down, you can see all the bits deploying. So 773 kilobytes. So deploys out. It's all fairly quick. And then you can see it's initializing the output. And it then, I'm holding it away long arm here, so it actually sees me and sends the pictures. So it's starting the plane protect project, and you get this quite often, that the SD card doesn't mount, and all you do is you have to stop it, pop the SD card out and in again, and then try again. And this again is a fault with the library, the SD card library, that we need to get fixed for the ESP32 camera board. So let's deploy that again. Just seeing in real life, it turns on the mains, you connect to chassis of the plane. So yeah, the problem is you don't have power out in the hangars, so you can't plug it in anywhere either. There's no Wi-Fi, there's no nothing. So you can see it's captured an image, and it's sent it up to cloud. And I'm going to do one from over there, so you get the different side of me, and send it up as well. So you can see there what it's doing is it's sending out. This is like £5-10 device with a little camera on it. and it's able to connect the internet using the house Wi-Fi, admittedly at the moment, but we've got plans for that. And it's sending those images up to the cloud. So it's taking a picture, processing it, connecting to the internet, sending it to the cloud, and then if I run the function as well, and we'll explain the function afterwards. So I run debug the Azure function. You will see here that the function will warm up and connect. You can see all the images have been analyzed that have been sent up, and you can see there what's happened with them. And you see the image analytics is in the image analysis of the function. And all I did was I said that I want it to connect out to my my vision AI, which I set up in the cloud, and I did no AI training at all. All I've done, and I must admit, like April, I just asked ChatGPT how to do this because I'm not an AI person, and I just said that I want visual features. I just want to find people. So if you see a person, tell me. Is all I wanted to know. And then what it's done is if I just let that run, you can see it's running down in the place here and looking at those images. I was kind of hoping I'd taken one where it see me. There you go. So you can see the bright lights come on. So that's a cloud to device message that's come from the Azure function, has triggered it, and it's gone out to IoT Hub and said, can you send this cloud to device message back down to the device, please? Azure IoT Hub has said, yep, I'm connected to the device. I'll send it an image as the other picture that was taken as well. So we can now use that. I'm just using the flashlight because that's what's on the board. We can use that to maybe start a siren, or the next part of the project is we'll get it to send a text message or a WhatsApp message or something to the owner of the aircraft, or maybe the farmer that runs a field, or maybe a local security, or even the police like ADT alarms and the likes do, to say this aircraft is being tampered with. Please send someone over to go and have a look at it, please. So they're the kind of things that we can do with this technology, all using really cheap boards. So I'm going to stop streaming. Actually, I'll go over and show you the what's going on with the in Azure Hub. So the Plane Protector AI, which is this one here, I did nothing. All I did was create an instance of it and grab the keys. I did no other work, and then it's using you see all the different libraries here. It's using the Vision one. But that's how you connect to it with the Azure function. You just connect to it and say, this is what I want. I want a vision and I want to find people. And that's all I did. I did nothing else other than get the keys to connect to it. I got the function up there as well in the cloud. I was running it locally, but it runs in the cloud as well. And then in my IoT Hub project, you can see I've got the devices, and when it loads, a Plane Protector 01 is the device that's you just see me using and running as well. And then there's a few settings in there. Defender for IoT is turned on as well, because why not? Because I've got the MVP credits, so may as well use them all. Stop Sander using all my my credits.
That will use them all as well. That
yeah, it will. And then in the Plane Protect images, if we go into the containers. You can see I've just got an image container and Plane Protector 01 because that's the device. You can see these are all the images that have been taken by the device, and the device name, and then it's the date, and which is the 16th. So today, isn't it? Yeah, and the time, which is just now when we've just been using it and playing with it. So you can see here, is quite a simple project in the cloud. It's quite simple on the device. There's quite a lot of potential with it that can be done, and it's just where we go with it next. So some of the things I'm going to stop streaming, and the reason I'm going to stop streaming is because I want to show stuff to the camera that's going to actually work. So you can see I've got ESP32, which is quite happily running, and you can see it's got a the board underneath. So I don't need that half of it. I just need this front half, which means I can 3D print a case and put a battery behind it. We talked about how there's no Wi-Fi in these hangars. There's no power out there either. So we do need to be battery backed with a solar panel, maybe on the hangar roof, and it's hidden up in the eaves of the hangar, so that they can't get to it. Rather than being inside the aircraft, it's up at height. Then there's using boards like this micro board, which allows you to put a 4G, 5G SIM card in the back, and then you can connect to the local cellular network. So I had a couple of these oddly gifted to me from Wilderness Labs, even though I'm talking about nano frameworks. Go look at Wilderness Labs boards as well. They do it slightly different. They still use an ESP32 and an STM chipset, but they have awesome boards as well. And the price has dropped considerably. I noticed the other day. They're down to around £40 per board delivered to the UK, which is considerably cheaper than what they used to be. So they are, fantastic boards. And again, full .NET, but they do it slightly differently. They all come from the .NET MAUI or Xamarin days. So they do it with full .NET and a slightly different stack. The other thing I found though, when I was looking around for things to buy on the internet, as you do when you're bored, I found this board. And this board here has got a battery on the back of it. So it takes a normal AA battery on the back, and it's got this SIM Connect chipset on the very end here, which then means that you can plug in an SD card, you can plug in your LTE SIM card on the back, and then that is an all-in-one board. It's got battery, it's got everything. So this cost me £35. I ordered it at lunchtime and it arrived at 7 o'clock that evening from Amazon. I'm not sure how Jeff Bezos makes it work and makes his billions, but he got it delivered to me super duper quick. And it's got the camera port just there, and that's in the bag that's out in the workshop. So it's exactly the same camera, exactly the same circuitry. But this is also a bigger chip. It's the S3 chip, so it's a much bigger chip with more memory, which then means you can do a lot more, take bigger images, because you won't be running out of RAM so much. Downside is, and the reason I haven't done my demo with this board is that Alan's library uses the ESP32 cam, doesn't work on an S3. I did try it, it didn't work. So that's the next thing, is porting that camera library into Nano Framework with Jose and the others, so that we can then use it across all the boards. I might even do a Raspberry Pi Pico version just for funsies. But it then means that we can make these. I'm going to make this. I'm not going to make it a commercial product. I'm going to make this freely available to anyone that owns an aircraft to download and build their own. But if I say to them, go and buy one of these, put battery in the back, put your SIM card in, and load this software onto it, it's going to be a lot easier for them to do that than it is to take an ESP32 and start wiring in things and soldering and stuff like that. Even though I think that would probably be much more fun to do. So that is the project. I'm going to make it all available on GitHub. I'm going to move you across because you're on the side camera, and make it available for people to play with. And you've seen how easy it is to take .NET Nano Framework and take your, a fun little project, a little idea, a little seed of an idea to take images and send them up, do people detection, then have a different engine that then decides to send a WhatsApp message or a text message to the owner of the aircraft. I'm sure if I learn a little bit more about AI, I'll be able to get it to learn the fact that the picture of the person is actually Bob, the local mechanic, and not to alert because we know Bob and Bob's a nice guy. But actually, Billy is the guy that keeps damaging the aircraft. So we want to tell the owner that Billy's in the hangar and go and make sure you sort him out and the likes. But that's the general idea. I've spoken to lots of friends that own aircraft. And I'm still kind of way away from that, but they're all really, really interested in this, mainly because they've all got Rotax 912 and 914 engines in their aircraft, and they're going missing very quickly, sadly, and turning up in places where we really shouldn't be seeing aircraft components turning up. But yeah, that's my talk. I don't know if anyone's got any questions or any feedback. This is the first time I've given this talk. It was put together over the last kind of 3 or 4 days, and yeah, it'd be nice to know what your thoughts are on the talk, and whether you think it's kind of a worthy kind of talk to put to other meetups and conference talks and stuff.
Yeah, that's definitely nice use of the equipment, and of course having the software to undergo it. My question to you would be, have you actually tried to calculate the power consumption of the device to see how long whatever battery you put against it would last without additional charging?
Yeah, we put a small solar panel, about yay big, again, that we just found on the internet. I think that cost about £12, I think it was, and then a small 3.7 volt LiPo battery. I think it was, I can't remember the size now. It's sadly, because I had to move in here, all the parts that I would just grab. So yeah, one of these is on my workbench.
I've got about 25 spares of them.
Yeah. So I've got a box of them out there, and the LiPo battery. So we had it on that, and we, just a very basic bit of maths. It was looking like it was going to last a couple of months off the LiPo battery in a solar cell, and that was it taking an image every 5 minutes. So go to sleep, wake up 5 minutes later, and then take an image. One of the things that I was tinkering with last night was getting it to, when it sends a cloud device message, to turn on the flash, get it to also at that time to then say, now start streaming images as quickly as you can, so that the person on the other end can look at it and look at those images and see what they're doing. Are they messing with the aircraft, or are they just kind of messing with their aircraft, which is the one next door, or are they stealing tools from the hangar, which is happening a lot as well. Because aviation tools are quite expensive, I'm sure you can imagine. So yeah, there's lots of ideas, what to do with the project. But yeah, it looks like it will last a good few months. And obviously, if you just put a bigger battery, it will last even longer.
Yeah.
Or a bigger solar cell.
Also, I heard you mention the LoRa communication option.
Yep.
I would suspect that it would not quite work for this application because of the graphics and the sizes of the data that's transmitted.
Yeah, I agree. It was just something we kind of briefly looked at to try and see if we could send the data. You can send it, but it will just be very, very slow. So because you'd have to send it as like kind of a packet of bytes, and it will just take a very long time to get there. But 3G, 4G, 5G will work a treat as long as there's cell reception where the hangar is. So.
No, is there a question?
There is, yeah. What plane did you begin training in, a Cessna or a Piper, from Ricky?
Both. I flew both at the early parts of my training. Cessna 152. Cessna 152 here in the UK. And then I did a lot of training out in the US, in Tulsa and Oklahoma, and flew a Cessna there. And I come back to the UK and did all my commercial. It's called a commercial license, but you're still doing a single engine light aircraft, and that was all done in the Piper PA-28 and a Piper Arrow, and that was in Stapleford. So Ricky, if you're London based, you may know Stapleford, which is Stapleford Abbots, Thaden Boyce, around that area, kind of northeast London, which is kind of, I grew up in East London, so it's the local airfield to me.
Well, how long did it take you to basically get your license? What was like the time horizon?
From being an engineer in Ford Motor Company and working on robotics and production line equipment at the Dagenham site, because that's where I grew up and that's what I did, to being an engineer there to being a commercial pilot took about 18 months. If you're interested, this morning at 9 a.m, British Airways opened their Speedbird Academy, and you can go from being, someone who doesn't fly planes, never flown a plane, to being a commercial pilot and having a job with British Airways, and they pay for all of it. You don't need to pay. They even give you beer money. They're that good. So I'm not joking. They do. They give you money for subsistence, which everyone just says is beer money because what it really is. But yeah, you can go on to if you look up British Airways careers.ba.com, you'll see on there, and the application is open. It opened this morning. It'll be open for a month, and you don't need any special skills. Don't need any licenses. You can apply. You just need to be between the ages of 18 and 55. And yeah, sort of, yeah, come and fly with me. Why not?
Thank you for that. I literally
Pete's
had a
already there with a
conversation.
link. Yeah. Where have you interest in aviation? Come fly. You know, where are you based in London?
South London, South London.
Okay, yeah, I'm in West London now, so I'm out near Heathrow for obvious reasons because that's where work is. So,
I literally came off the flight a week ago. I was speaking to a pilot, and he was literally telling me about that program. But I didn't know the fact that you're literally telling me that it's literally being open this morning is timing.
This one. We've got the company put out I know this has gone away from IoT and is geeky in a different way, but the company put out a message last week that says over the next 10 years, over half of our pilots will be retiring. So they're panicking big time. They're like, oh dear, we've got no pilots to fly the planes, and you know they're trying to recruit as many as they can. It's about 200, 250 people a year we're recruiting, a fully paid for scheme. And when it takes someone from being on the street to being a commercial pilot, it's about £120,000. It's a big investment from the company. So yeah.
But back to Internet of Things.
Yep.
Quickly, just want to ask you about like, so right now what you've built here, I think is very important. And how would you get adoption going in that case?
I think for this one, because it's quite I mean, it could probably be used in other industries. You know, you could probably use it in other places where you can't get a Wi-Fi signal and it still work for you.
Use it on boats.
You could literally use it anywhere where you can't get a Wi-Fi signal, as long as you've got a phone signal. But the people I know at the local airfield that've got aircraft that sometimes let me borrow them to go flying on a small plane, they are very interested because, you know, engines they're worried that their engine's going to get taken and the aircraft destroyed. They're worried about their tools getting stolen all the time, or people coming in and damaging the aircraft because they don't know how to kind of walk around and look after an aircraft. They're just at the airfield having a look about, you know, and you know, they damage the aircraft and don't realize that they've damaged it and walk off. And now, you know, the pilot then may sort of go flying a week or two later and not realize that they've damaged the aircraft, and you know, could end up in an incident. So you know, that's things like that is securing the aircraft as well as kind of protecting it from sort of the baddies that might want to steal bits from it.
Thank you for that.
Yeah. But yeah, if you want to stick it on a boat, that'd be kind of a cool project, wouldn't it? Just take it and stick it on a boat. Need a boat then. So I'm not sure my accountant would spring for a boat. She'd probably tell me to where to stick it, you know.
I suppose to a certain degree, a different version of this, literally thinking on my feet now, to have some sort of actual, it's not really motion, but some sort of sensors on the aircraft itself, which would have certain triggers to proceed with the rest of, like, start filming or whatever it might be a type of situation. So if the aircraft has got a movement without the owner or someone kind of present, then you immediately get notified of what's going on.
It's one of the things considered was putting accelerometers on there and an IMU, etc. And then the next kind of, my brain then jumps 20 steps ahead, a bit like you, April. And it was like, that's really cool because light aircraft don't have black boxes. So when there's an incident, it's very difficult for the accident investigators to piece what was the aircraft doing before the incident. So if we've got accelerometers and we've got data capture to an SD card, why not, when the aircraft's being used, capture that accelerometer data and maybe take an image, because there's a camera on board, maybe take an image every 20 seconds and store it to the SD card. And then if there is an incident or an accident, then they can take the SD card and it's just normal files they can read and look at, store it as JSON or something really simple. Obviously the SD card could probably get destroyed if it's a fire or something, but it's a it's a way of doing that, or maybe send the data literally to the cloud that you're flying through. There's kind of that's kind of next steps. For me to start with, I want to get it working on this board, so that I can just buy these and give them to people and say, right, go and stick that in your aircraft.
I think the key component here is commercially viable, and by saying commercially viable, I mean the attainable without having a significant expense,
or skill set.
And sometimes skill set as well, which is you still need to have certain amount of skill set or someone to help who has it, which you evidently do to have set it up, so you can kind of share with a common interest, share in the community. Because I do certain, well, not really do, but I've got ideas and I have played around with the actual kind of implementation, but never did anything practically, unfortunately, to do it. So I implement the concepts, and I have done with it a fair few bits with ESP devices.
Yeah, they're great. It's just normally you have to write it in either Python or C++. C++ I can do. I don't mind doing it, but it's just I prefer not to. And Python, I don't know. It just always feels like I
Careful.
No,
Python advocacy.
No. I'm just saying. I always find like I'm. Yeah,
it is MicroPython, and it's got its own downsides.
Yeah. I just find that I don't know. I find it harder. My brain struggles with it. And whereas C# I seem to be quite happy, but that's because I do a lot of C#. The only other thing I want to do is plug Jose's awesome book. If you've not played with Nano Framework, it's an amazing book. It starts off really, really simple, like literally getting it to flash an LED, and moves all the way through to some very complex, like, towards the end, it starts talking about testing frameworks and stuff like that, so you can test your .NET code. It's an amazing book. I was hoping to take mine to Summit this year to get Jose to sign it for me, but I didn't make it, sadly, to Summit. But
you'll just have to fly to Portugal. That sounds like a horrible thing to have to go and do.
Yeah.
Let me know when you go.
Yeah, will. But cool.
And people, when you say fly yourself to Portugal, you mean literally fly yourself.
Yes. Get the sling built.
Yeah.
And we'll bring port back.
Yeah, that sounds like a wonderful plan. Yeah, or NDC Porto, maybe go there.
Yeah, we can make it a double stop, and we can call off and see Sander on the way as well.
Yes.
It's not on the way.
It's not, no, but it's close.
Yeah. That's great. Really enjoyed that. Thank you very much.
Yeah, so
really great.
Happy if anyone's got any feedback on it. I kind of threw some slides together, and I wanted to walk through the code, and that. But hopefully it's you got the idea of the project. None of it is particularly difficult C# code. And it's just knowing the libraries.
Yeah, great stuff.
Cool.
Excellent. So thanks so much to Cliff and to April for their talks.
Yes.
Awesome stuff for coming along. As I mentioned before, we've got a .NET Knots a week on Monday with Luce Carter talking about MongoDB and C#. So that's unfortunately you're gonna have to be in Nottingham to come to that. It's a workshop, but nonetheless, that will be very good. And then just keep your eyes on the socials and on Meetup for future Knots IoT events.